So today we're going to build an API for dog walking. My girlfriend is currently starting a dog walking business, and like any good boyfriend, I'm going to, of course, create a Rust API for her. This is not really the performance-intensive task that Rust is necessary for, but I hope that if we go through how you can build an API for something simpler, it'll give you the foundations for building an API for something more complex. This is aimed at beginners to Rust, but not beginner programmers. So I'm not going to talk about what an HTTP server is, what a server is, or go into much detail about Mongo. If you think those topics would be interesting, let me know in the comments. But for now, let's dive in and build our HTTP dog walking server in Rust. If you're new to Rust, you can check that you've got it installed, the Rust C command, and also we want to check cargo. Great. So these are the versions that I'm working with. And now I'm going to start a new project by writing cargo new Rust server tutorial. And we are going to code. Okay, now we're in our Rust project. And the first thing that I'm going to do is add a bunch of dependencies. So we are going to write cargo add. Actix-web is the framework we'll be using for our server. Chrono for time, just util will help us with our asynchronous code. MongoDB for our database, and surd for serializing and deserializing data. Now we're inside our main.rs function, and instead of bringing something to the console, we are going to return an HTTP server. So to do that, first I want to return a type of result. And then in here, we're going to return an HTTP server from Actix. We want a new one. And we want a new app. We're going to implement a service that we'll write in a second called hello. Right, so then we want to bind this to localhost, and I'm going to choose port 5001. Then we're going to run, and lastly, we are going to await. Shouting at us for a couple of reasons. We need to import app. And now I'm going to write my service. Oh, getting one thing. In order to get the HTTP server functionality, we need to use an attribute that triggers a macro. That's going to make main behave in the way that we want. So that's going to be hash actix-web main. Okay, and we also need this function to be asynchronous. Okay, and now we can write our first route. This is also going to follow an attribute pattern, so hashtag get, and this will be the main index route. An async function called hello. This is going to implement a responder. And this returns an HTTP response. Okay. That's like a status 200 response. And I will say, hello. Is our Rust server. We have a route, so we can now run it. And I'm going to run it using cargo watch C flag for clearing the screen. We're going to tell it where to watch. Source folder, and X run means that the watch command is only going to run when a change is detected. Great, so now we can go over to our browser. We can visit localhost 5001, and we see hello YouTube. Cool. This is the basis of our server. Let's add some routes. We're going to be building an API for a dog walking business. So we're going to create some routes to make a booking, add owners, add dogs, and cancel a booking. The file structure of our project, I'm going to create 3 new folders. Models for the database models, routes for our HTTP routes, and services where we'll handle the database connection. So let's make those. And then we're going to start with the models and defining our data structures. So if we go into the models folder, we're going to now create models for bookings, dogs, and owners. So we've got booking model.rs, dog model.rs, and owner model.rs, and we're also going to create a mod.rs for exports. Cool. So if we go in there, we now have all of our files. Okay, we're going to start with the booking model. So I'm going to create a new public data struct. Rid of that. Called booking. And this is the data structure of what we expect to end up in the database. So we're going to be using MongoDB data types in this one. We are going to have an ID, which is Mongo type, an object ID. Okay, let's start by importing Mongo. MongoDB, bsun. Great. Okay, we're going to have an owner. That will be a reference to another collection, so we need another object ID. Start time is going to be a date time. Also import, and then we'll have a duration of the walk. It's good practice to put the units, so let's say in minutes. And this is unlikely to be more than a couple of hours, so we can fit it in a U8. And we'll also give the functionality to cancel. We want to be able to mark it as cancelled. Cool. Okay, last thing to do is just make sure that all of these fields are exported, and we will do exactly that. Hub mod model. Okay, and then I do want to go back to the main file and just declare mod models. Should link everything up nicely. Okay. And there's one thing I forgot to do, and that's we want to give this data structure the ability to be serialized and deserialized. And also we want to debug it. Let's derive debug, serialize, and deserialize. Sweet. Okay, so this is a good data structure for our database, but it's not going to be a great data structure for our API users. Instead, we're going to want to enable them to provide things like a string instead of a date time, and we're not going to expect them to come with an underscore ID. So how do we do that? Well, the common pattern is to have a separate data structure and then to implement a way of converting from the request to the database structure. So we will copy this, but instead our new data structure will be booking request. And then inside it, we'll have just an owner, start time, and duration. These top two are going to be strings. So how do we convert from strings to the format that we want? We are going to implement a try from. You can also implement a thing called a from, but a try from can fail. And as we're dealing with user submitted data, which could be unexpected, we need to account for the possibility of failure. So we are going to implement try from with a type of booking request, and this is for the booking type. Before we go any further, I'm just going to create a generic error type for whatever errors might get returned. So the type error is going to be a box, and then a dynamic standard error of type error. Any of those. And then inside this, we have a function, try from. I want to call this item. And Probably the most tricky thing to convert is going to be our date time. So I'm going to do it in 2 steps. We're going to use the chrono crate, which is a popular crate for time operations in Rust. So first we're going to create a chrono date time. This is going to be of type system time. We will import function pass from RFC. And the one we want is this one, 3339. And in there is going to go borrowed version of our item start time. This could error, so we want to handle that. If it errors, I want to print that failed to pass start time, and whatever the error is. Then we'll specify our time zone. Question mark, so that we can use the result of this with time zone. And we'll say we want to use UTC for that. And then lastly, we'll put into function that will convert this to a system time. Great. Now we have that, we can probably go ahead and start returning our result. Okay, the successful case is that we return self, i.e. type booking. This has an ID, which will be a new object ID. Next is the owner. So this, we can use the pass string function on the object ID, and we'll pass in the item owner. And I'll add some error handling as well. Failed pass owner. Now for the start time, because we did the hard work above, we simply have to use August date time, and we can get it from chrono date time. And finally, cancelled, we'll just put in a default value of false. Okay, let's save that. It doesn't like self. Oh, we're missing duration in minutes. That one's the easiest. You don't have to do anything. Now we have a booking object that is going to represent the database type. We have a request object that's a bit simpler and can be used by the end users of our API. And we have a function convert from one to the other. So now we know the formula, we can do this for the other type. So next, I'm going to go to the owner type. In fact, let's copy this across. Right, so this time instead of booking, it's going to be owner. And owners are going to have some different things. So they'll have an ID, but everything else will be different. So we want a name. We want email, phone, and an address. And we'll say they can all be strings. So the only thing we need to worry about in our conversion function is this ID. Let's therefore copy across everything else that we want to keep. And then down here, we don't need to worry about dates or times. This line can stay the same. And then all these fields simply be item dot and the name. And it's going to be similar for the dog model. Let's copy the owners and we'll rinse and repeat. This time instead of owner, we are dealing with dog. And I think we'll put the reference to the owner on the dog. So this is an object ID. Then the dogs can have a name, maybe an age. Again, dogs sadly don't live very long, so we can use a U8. then a read. And I think that these pieces of information aren't going to be critical. So what we can do is wrap them in an option type to signify that they might not be there. So in our requests, we're not expecting people to provide an object ID format, so that's going to need to change to a string. But everything else can be the same. Object ID becomes a string. And then in our conversion function, we're just doing 2 conversions. So go back up and grab these. Right, most of these can just be taken directly, but the owner is going to be an object dot owner, and I'll add an expect for good practice. L2 pass owner. And I've noticed we've not been getting IntelliSense because we need to export our new models. Dog and owner. Oh, now that I've done that, I'm getting some unhappy noises. Oops. These should say dog. And these should say owner. Okay, the next thing we're going to build is our database server. So head over to the services folder, and I'm going to create a new file called db.rs, and then as usual, mod.rs. Services.rs as well. Okay, so then if we go back into our database file, the first thing that I want to do is create a data structure for our database. This will need to be exported. So we'll say public structure database, and that's going to contain a booking, which is a MongoDB collection of type booking. And then we'll add others. Dog is a collection of type dog, and owner likewise. Okay, great. The next thing to do is implement this database and give it a way of connecting. So we are going to implement our database, and we're going to give it an init function, public async of init, which is going to return database itself. That's itself. Right, so in this video, we're going to presume that you know a little bit about MongoDB and how to connect to it. I'm not going to run through how to set up a local instance, but effectively, when you have a MongoDB database, whether that's online in the cloud via something like Atlas or locally, you have a URI string. So I'm going to use a local string, and I'll also use the environment variables library that comes with Rust, so that if you wanted to, you could also provide a URI that way. So we're going to say let URI equal, I'll do a match, and we'll use the env library, env-var. So either it'll take an env-var called MongoURI. If it finds one, that's okay, and it will turn it into a string like that. Or if there's an error and it doesn't find what it's looking for, it'll grab a local URI string. Okay, and to stop the red lines, I will return base with booking dog owner. So next we need to create a client for our database. So let client equal, and we can import the MongoDB client with URI string, URI. I will wait this, and then I will unwrap it. Then we're going to create our database with name, so client.database, and I'm going to call this dog walking. And then lastly, we just need to define our collections. So let's let booking be a collection type booking. And all we have to do for this is call the collection function and pass in. Again, we will do this for dog and owner. Just a little cleanup. So now we should be able to initialize our database, and I'm going to go ahead and do that in our main.rs function. So before we return the HTTP server, let's define a new database so we need to import our own database. We want to run init, and we wait for that. And then we're going to use Actix to create a data object. So let db data equals data new, and take our database. And then we can pass this into our app. So before we define our service, we can specify want db data, going to clone it. And we also need to import data from Actix, where we're getting an error here, and I will show it to you. Closure may outlive the current function, but it borrows db_data, which is owned by the current function. And we have some suggestions of how to solve it. Force the closure to take ownership. Use the move keyword. Okay, let's do that. Okay, our work on the database layer isn't done because before we create our routes, we're going to want to write database functions to do all the things that we want our routes to do. So to start with, we're going to want to expose endpoints that allow somebody to create an owner, dog, and booking. So each of these functions will be pretty similar. I'll write one, and then it should be a case of copying. So we want a public and a synchronous function called createOwner. It's going to reference database, and it will also accept an argument of type owner. And we anticipate that we want to return and set one result or an error. I think we want this. In this function, let's define a result, self to reference the database, and it's going to be .owner for the owner collection. And we'll use the Mongo method. Set one, we're going to set an owner. We're not passing in any special options. We need to wait for this, and then we will call OK. And for good measure, I will add a little error message for creating and return our result. This we can repeat twice for our two other data types. So we'll do create dog. This will be dog, capital D there, and similarly down here. Right, the next thing that I want to do is create a function to cancel a booking. This is going to be ever so slightly more complicated, but it's not the most complicated one that we're going to write. So let's define public async function of cancel booking, and it's going to follow a similar format. So we've got self, and this time we'll just ask our users to provide a booking ID of the booking they want to cancel, and this can be a borrowed string type, and we'll use our expected Mongo type, which is now an update result. This time we're going to let our result equal self.booking, and we're going to call update one. Okay, to write more complex operations with Mongo, we need to use the doc macro. So for our query, that's going to be a doc exclamation mark. And we are looking for the document that has an ID of whatever string has been provided turned into object ID. Booking ID, unexpect, failed pass ID. Okay, and then the update will also be a doc. In here, we are going to set a new field, and for those familiar with Mongo, you have to use the $set syntax. And here we are going to simply change cancelled to true. There are no options, that's none. I'm going to await. Okay, and finally we can add an expect. Okay, result. Oops, semicolon. This is my bad habit from many years of TypeScript. Better. Cool. Right, finally, best till last, we're going to write a function to fetch all the bookings. This is not so much about Rust as about understanding the way MongoDB works. We're going to write an aggregation, which is basically a series of MongoDB operations in one single database interaction. So don't worry too much about what this looks like if you're not experienced with Mongo. I'm not going to go into a massive amount of detail, but essentially what it does is it's a bit similar to joins in SQL. We're going to look up the dogs and the owners and attach those to the bookings so we get an object with everything we need in one place. Let's call our function getBookings. Right now, we're just going to get absolutely everything. And we want to return a vector of booking type with everything else. So we're going to need a new type for that. Let's call it full booking. The compiler is going to shout at us, but we'll come back to that. All right. Right, this time we're going to have multiple results. So let results equal self dot booking. And we are going to do an aggregation. Again, I don't think we're going to need an option. For this, we want to use a vector type. And then each of the aggregation steps is going to use the doc macro. So let's say doc. First, we want to have a match step. And we're going to be matching against, we want anything that isn't cancelled equals false. And we probably want bookings that haven't started yet. So we're going to say start time is greater than or equal to now. So let's say we want a MongoDB datetime. We're going to get it from system time, and we'll use UTC now. Oh, and we want to convert that. So let's put that up here. That's now a type of system time, UTC now, and then we'll just use into to convert it. That is the first step. Next, we're going to look up the owner relevant to the booking. So this is going to be a lookup from the owner collection, local field, that's whatever it's called in the booking collection, is also owner. Foreign field, simply underscore ID. And in the lookup, we want to call it as owner. That's going to give us an array with the owners in it, but we don't want an array. So the next step to use is an unwind. Doc unwind. Doc, the path of owner. And we're going to do something similar with dog. So I'll copy this lookup from the dog table. This time, the local field we'll be using is the underscore ID of the owner we've just fetched. Foreign field is the owner, and we're going to call this dogs because there could be more than one. Wait. Okay. And expect. Error, getting full bookings. let's save that. Oops. What? Okay, we still don't have a full booking type. So maybe now is a good time to implement that. So if we go back into our booking model.rs, I'm going to add a new struct. I call full booking. Okay, this is going to have all the same things as the booking plus some extras. So let's copy those fields we know we have, but we're also going to change the owner field. That is now being looked up from another collection, and we've got the entire owner. So this will have type owner, and we will also have a vector containing dogs. So now we should be able to import this full booking. One error is gone. Now we've got a new one. So we go to the end of our aggregation. Right, we're going to have to do some work to get our bookings into the right format. So let's start by creating a new vector. Let mute bookings be a vector of type for booking. And that's a new vector. And actually, maybe I can bookings. Now we're going to have to loop through and push the bookings from the format they've just come back in into our vector format. So I'll use a while loop. We'll say while let some result. Then we want to do results. Next, that's from the futures library that we added at the beginning. Dot await. What this is going to do is it's going to go through the bookings one by one, and then we can do a match on the result. So we match result. If it's okay, then we get a document out of it. So let's let one booking be a full booking, and it's going to be from the document doc. We'll have an expect that says error converting document to full booking. But if it works, we'll push it into our vector. Bookings push. Ooh, missing an S. Okay, and if something goes wrong, then we have error, error, and we'll panic. Error getting. And there will be some text that we can add there. Cannot borrow result as mutable, as is not declared as mutable. Aha! Happy now? Brilliant. Okay, at this point, we have all the database functionality that we want for our MVP. So all that's left is to create the routes. Creating the routes is going to follow a similar pattern to creating the models. Okay, so we're going to cd into our routes directory, and then we are going to create a bunch of files similar to what we did for models. So it's booking root.rs, dog root.rs, owner root.rs, and mod.rs. Before I do anything else, I'm just going to quickly now routes, and we will add the mod of. I think this time we'll go in reverse order. We'll start with dogs, and this bit really is just the glue that stitches everything together. We've already done the hard work creating the database interactions. This is something that Actix helps us a lot with. I'm going to start with dogs and owners because all we want to do is surface the ability to create each of those. With dogs, we will use post attribute, signal that it's a post request, and we'll call the root dog. All right, and I'll follow similar naming conventions to the database. So we're going to say public asynchronous function to create a dog. Okay, we're going to want to pass in a database that will be type data database. Make sure to choose database we've defined in our services. And the other argument is going to be the request. Actix gives us a JSON type for this, so JSON dog request. This is going to return an HTTP response. I think I'm going to do matches for all of these, so we'll have a match db create dog, and then we can now use our try from conversion function that we created when we were making the models. So dog try from, and we'll be dog request. And this really is the simplest, as we just need to clone everything. So owner request dot owner dot clone. Then we'll do that for name and for age, for breed. If there's a problem, we will say error converting dog request to dog, and we'll await it. Okay, if that's fine, then we should have a dog, and we'll get HTTP response. Okay, JSON dog. And if there's a problem, we'll have an error, and we can return an internal error. So HTTP response, internal server error, all that. And the body of this can be the error we've got as a string. We can copy this pretty closely for our owner. Dog is going to become owner everywhere. Owner. And let me capitalize all the data structures. And owners have a few different properties. They have a name. They also have an email, a phone, and an address. Okay, I think that is everything. So lastly, we have the bookings. We'll start with a create function, and then we'll implement the cancellation and the fetch for all the bookings. So the create is going to follow a very similar pattern. All going to be booking. Okay, bookings have an owner. They have a start time, and they have duration minutes. 2 more functions to go. The fetch function, which was quite complex to write on the database, is going to be very simple because we've done all the hard work. So this will just be a simple get request, get attribute from Actix. We will call this root bookings. Public async function get bookings. This accepts an argument of our database as before, and nothing else. And this is going to be much simpler. So we're simply going to run our get bookings function on the database, wait it, and then follow format above. Lovely, nice and easy. Finally, we have our route to cancel a booking. And I want to make this route take a dynamic ID. So I'll show you how to do that. Let's use put, which would be fine too. And I want our route to be something like /booking. Then we'll have the ID, so we can do that with curly braces. And then we'll say cancel. Right. I'll copy the function above. It's going to be similar, just with a difference, which is how we get access to this ID. So the way we do that is by specifying a second argument of path. And this is going to have a type path. The type inside the path is a tuple type. So we just have one string. And then to get access to that string, so we define a variable called ID, we can run path dot into inner. And again, this is going to return a vector, so we just need to grab the first item. And then instead of get bookings, we can run database cancel booking, have our ID, and we just want to call this cancel booking. Oh, we need to borrow this, so we can use .as string. There's one final thing to do, and that is actually to tell our HTTP server about all these routes. If we go back into main.rs, here where we've called service and specify hello, let's add all of our other services. I think there are 5. Create booking, create dog, create owner. We also want to get bookings and cancel. Now all that's left is to run our watch function again and see if we can try out our routes. So cargo watch. Then I'm going to open up Postman, and I've prepared some requests for us to try. So here's Postman. Here's an owner request. Inserted something into our database here. Then let's use the ID of the new owner to add a dog to that particular owner. So we'll add one here. In fact, let's add 2 dogs. That will be fun. I'm using my grandparents' dogs as inspiration. We'll say Barney, the poodle, age 8. That. Okay, now we have 2 dogs. Then the booking. So we'll use the owner ID again. We'll say that, yeah, it starts in May. It's a half-an-hour walk. Great. And I'm going to keep a hold of this ID so we can cancel that booking. First, let's fetch it and see what we get back. So this has no body. It's a simple GET request. And that is good news. So we have the ID of the booking, all the owner information here, and 2 dogs, 1, 2. And the remainder of the information. So that's great. That's absolutely everything that we need. We can see it all in one place. And finally, our put update request. We're going to ask for the booking with the ID we just got to be cancelled. Send this. Mongo is sending a modified count of 1. So then what should happen if I run the get again is that this should disappear because the booking is now cancelled. And it's gone. We've got an empty array. So I hope you found this tutorial a useful introduction to building HTTP servers in Rust. It's my first tutorial, so I welcome any feedback. Filming a video was harder than I expected, so I'm gonna see if I can mix things up a bit for next time, but I hope it was useful. Thanks for watching.